Let's talk about order of operations. So why do we need a particular order of operations? Well, when multiple operations are involved in an expression, they have to be done one at a time, and you might get a different result depending what order you do them. So if we have 2 plus 3 times 6, if you add and then multiply, you take 2 plus 3 and get 5. 5 times 6 is 30. If you multiply and then add, you would take 3 times 6 is 18, and then 2 plus 18 is 20. Two different answers, only one of them is correct. We want to have expressions have a single answer. We don't want it to be ambiguous that it could be multiple different things. So general rule, operations and symbols group values and expressions. Different operations and symbols have different strengths or levels of grouping. Calculations are done in decreasing order of grouping level or strength. So stronger grouped calculations are done first, and then the least strong grouping is done last. So we have these levels of operations. So level of 4, the highest level, the first level that would be calculated is grouping symbols. If there are grouping symbols inside of other grouping symbols, you work your way from the innermost grouping to the outermost grouping. So you think of kind of those, if there are multiple grouping symbols surrounding a calculation, that's adding levels, making it a higher level. Then we have the operation levels below that. So the highest level operation, exponents, square roots, logarithms, then the next level down, multiplication and division, and the lowest level, addition and subtraction. Same level operations can be done in any order as long as you think of subtraction as adding negatives and write division as multiplying by the reciprocal. So example, with the subtraction, if we have 3 minus 5 plus 2, that's really addition of 3, negative 5, and 2. So you can't take 5 plus 2 because it's not a 5, it's a negative 5. So you could take negative 5 plus 2, but you wouldn't take 5 plus 2 and then subtract that total from 3. With division, 30 divided by 6 times 5, it's really 30 times 1/6 times 5. You can't take 6 times 5 because 6 isn't a factor. It's on a different, would be on the denominator if you're doing it as multiplication. So you can take 6 times 5, but you could take 1/6 times 5 and then multiply that result by 30 if you wanted to. So again, think of things that way. Think of the negative sign as always going with the number that follows it, and think of division as a fraction. And again, in this course, you typically won't see that division symbol anyway. You'll see that as fractions, so that shouldn't be an issue. And as long as you have those in mind, then the same level can be done in any order. They can be moved around, rearranged as needed. All right, grouping symbols. So a horizontal fraction bar groups what's on the top and the bottom. A square root symbol groups what's inside of it. Absolute value symbols group what's inside of them. Exponent position groups what's in that position. So those are all operations, really. The horizontal fraction bar is division, the square root symbol is square root, absolute value, exponent. So they're operations that also kind of have a built-in grouping. But then we use parentheses that so isn't really an operation itself, although it can kind of mean multiplication just by the it's really the juxtaposition of the things being next to each other that are multiplication, though, rather than the parentheses. The parentheses are just used to clarify the juxtaposition. Other grouping symbols, so those operation-based grouping symbols may have to be replaced with parentheses to accomplish the grouping if that operation is written in a different way. So if instead of the horizontal fraction bar, you're writing the division all on one line, then you would need to group the top and the bottom with parentheses. If the exponent is written with the caret symbol rather than the exponent position, you'd need to group anything happening, any lower level operations in the exponent position would need to be grouped using parentheses. So that type of thing is going to, again, depend on your specific calculator, whether you need to add the parentheses, depending if it loses that positional type grouping. All right, so you probably have learned order of operation as parentheses, exponents, multiplication, division, addition, subtraction, PEMDAS. Please excuse my dear Aunt Sally. And that works. A couple of things why I don't approach it that way. Because you have to remember extra things besides just the PEMDAS. You have to remember parentheses isn't just parentheses, it's all those different groupings. Multiplication and division are on an equal level. So if you just think of it as multiplication and then division, if you're given something like 30 divided by 6 times 5, you might think, well, I got to multiply the 6 times 5 first and then do the division, and that's not correct. Addition, subtraction also are on an equal level. So again, 3 minus 5 plus 2, you wouldn't first do the addition of 5 plus 2. So just different things where PEMDAS can go wrong if that's all that you remember. And I think thinking of it as kind of these levels of operations, if you kind of get a instinctual understanding of that, then hopefully it will make sense without having to think of a mnemonic to go through the order. All right, some practice of order of operations. So we have 5 times parentheses 3 plus 4, and then plus 2. So the 3 plus 4 inside the parentheses is the strongest grouping. So that is done first. So then we have 5 times 7 plus 2. The 5 times 7 is the next strongest grouping. So that happens 35 plus 2, and then we do the addition. 2 plus 5 over 2 plus 4 times 7. So the strongest grouping is the 2 plus 5 being grouped on top, and the two, so those top and bottom grouping symbols. 2 plus 5 is 7. Then within the 2 plus 4 times 7, the 4 times 7 is a stronger grouping that happens first. 2 plus 28. And then still the 2 plus 28 is a stronger grouping than the division. This would be 7 divided by 30. And then typically you'll leave answers in fraction form here, simplified fraction, but you wouldn't give that as a decimal. All right, and then we have these multiple levels of parentheses. So the 10 plus 6 is grouped within parentheses and multiplication and brackets. So it has these multiple levels. I'm going to do that first. So we have then 2 plus bracket 4 plus 2 times 16. The brackets are the same thing as parentheses. Basically, they're just, when there's multiple levels, they tend to alternate parentheses and brackets just so it's easier to keep track of kind of where they each start and end. So we now have 4 plus 2 times 16. The 2 times 16 is the stronger grouping inside of those brackets. So 2 plus 4 plus 32. And then we have, really now these brackets aren't doing anything because we have 2 plus and then 4 plus 32, but you can still do it in order. 2 plus 36. And then the brackets really aren't doing anything. That's just 2 plus 36 with, and that's 38. So yeah, when you have all the same level operation with brackets or parentheses, at that point, the parentheses are grouping, but they're not really changing the level. Everything's really on the same level. All right, 2 times 3 to the 2 plus 1. We have the 2 plus 1 in the exponent position grouped by its position. So that gets done first. 2 plus 1 is 3. And then the power is the higher level operation. So it happens first. 3 cubed is 27. And 2 times 27 then is 54. Then we have 3 times square root of 4 plus 5 minus 2. The 4 plus 5 inside the square root is the first thing to do. Highest level of grouping. 4 plus 5 is 9. Then the square root is the next, the highest level operation happening. Square root of 9 is 3. So we now have replacing, because we don't have the grouping of the square root symbol anymore. So I put parentheses around the 3 so that we still see that juxtaposition. That means multiplication. 3 times 3 then is the next operation level. 3 times 3 is 9, and then the minus 2 is 7. Next example, 3 minus 2, absolute value 4 minus 5. Absolute value, pretty much as far as order of operation level, is like parentheses, but the absolute value does actually do something to what's inside of it. So in a way, it's kind of like a square root symbol also. It would come before you would multiply or add to whatever's inside of it. So it's maybe on an equal level with exponents. Or with grouping symbols, I guess, even above exponents. So what's inside the absolute value grouping symbols gets done first. And I'm going to write this absolute value signs kind of extra long so that they don't look like a number 1. So absolute value of 4 minus 5 is -1. Then the absolute value actual operation comes next. And so absolute value, just if there's a negative on the number inside of it, turns it into positive. But again, only after any calculations inside of the absolute value have been applied. So absolute value of -1 is +1. And now that I don't have, I've done the absolute value operation, that I don't have those symbols anymore, I use parentheses to maintain the multiplication. 2 times 1 is 1. So this is now 3 minus 2, which is 1. And then last example, we have -4 plus square root of 4 squared minus 4 times -5 all over 2. So everything on top of the fraction is grouped by the fraction. So that's all got to be done before we can do the dividing by 2. Inside the square root then has to be done before the square root is applied. And we have the 4 squared done first, and then the -4 times -5. Some of these, if they're kind of separate, so we have the subtraction, the addition subtraction, but then the multiplication. So since both the exponent and the multiplication are above the addition subtraction, then it can do them, since they're not interacting with each other directly, I can do them both in the same step. So -4 times -5 is +20. So then I do that addition within the square root, because it is still a higher level than the actual square root operation, because it's grouped by being inside that operation. 16 plus 20 is 36. Now I can do the square root. Square root of 36 is 6. That is still then, that's addition. So I don't need to add parentheses around that because I don't need to maintain juxtaposition or anything like that. Then the -4 plus 6 grouped by being on top of the fraction. So those get combined first. And that's 2 divided by 2, which is 1. So that's order of operations.